Hello everyone, welcome to STEM with Chantel. I'm Chantel and this is Ty.
Hello and welcome to a Jessamine County Public Library STEM mini-series. This is STEM in Railroading.
Hey everybody, my name's Adam Harris. I'm an employee of RJ Corman. I work for the mechanical department as a locomotive electrician, and today we're going to go over a few things about how a locomotive operates. So on most locomotives, they're all identical. We can go over a few of the parts that make up the locomotive. What you see here is what's called a truck. The truck is designed to hold the individual traction motors. There are different locomotives out there. Some are 4-axle locomotives, some are 6 axles. This one itself has 6 axles, so it's 3 traction motors per truck. These traction motors are a DC motor. They take the electricity made from the generator and we apply it to the traction motors, which produces tractive effort. Another part on here is the brake cylinder. So each truck will have a couple sets of brake cylinders, which is actually what we take the air pressure that the air compressor makes, and we use it to push out the cylinder, which in turn applies a brake shoe to the locomotive wheel and allows you to stop the train. So on every locomotive, of course, in order to power the diesel engine, you have to have fuel. On this locomotive, it has about a 4,000 gallon capacity fuel tank. As you can see, the fuel tank is designed to meet certain criteria, hardened steel in the event of an accident. It's designed to be puncture proof. I think some of the other locomotives that we have are roughly 3,000 gallon tanks, but since this is a 6-axle locomotive, it'll have a larger tank. Another thing on here, on both sides of the locomotive will be a large air tank. This locomotive and all of the ones that RJ Corman have come equipped with 2 air tanks. One will be a primary, one will be a secondary. One will always provide air to the air brake system, and the other will be used for auxiliary purposes such as sanding, windshield wipers, and so on. So on every locomotive that is built in North America, they will all have a large coupler like this. This coupler is mandated by the Association of American Railroads, so that every locomotive in North America will have the same style coupler. And the purpose of that is that any locomotive can be coupled, or any rail car can be coupled together without an issue. Also back here you'll notice is a large electrical jumper cable. This is a jumper cable. It has 27 different cables or pins inside of it. What this is used for is when we connect 2 locomotives together, we can connect this 27-pin cable so that whatever you're doing on the lead locomotive, it will tell the trail locomotive what to do. So we'll talk about a couple of the components that are inside the car body of the locomotive. The first thing we come to is the air compressor. The air compressor does what it says. It compresses air and provides it to the locomotive operating systems. The air compressor does a couple functions. It provides air for the brakes, which is the most important part, but it also provides functions for to apply sand to the rail. Some of the windshield wipers are pneumatically operated. Another section to the locomotive is what's called the Michiana tank. This Michiana tank is actually what holds the oil filters for the engine. Just like your automobile that you drive every day, you have to have oil filters to help protect the engine. This tank specifically has 7 separate filters. These get changed every 92 days as annual maintenance, just like you would take your car to a Valvoline and have the oil changed. In this compartment, there's a few things I want to touch on. The primary thing here is fuel filters. Same thing like I mentioned about the oil filters of your car. You have to change the fuel filters to keep contaminants out of the fuel system. Another thing in this compartment is a water pump. So this locomotive has 2 water pumps. It takes the water out of the holding tank and pumps it through the engine to keep it cool. And the last thing I want to talk about is it's called a Locomotive Governor. The governor is what allows us to tell the engine to produce an RPM, or to idle up. So what you can see behind me is the diesel engine of the locomotive. This diesel engine happens to be a 16-cylinder. Each cylinder is 645 cubic inches. One thing about it is at the bottom of the engine is the oil pan. That oil pan holds 250 gallons of oil. Unlike a normal car, it might hold 6 quarts, so you can do the comparison there. All right, so in order to get the diesel engine to run, it takes a lot of air. In order to get that air, it must be forced into the engine. And what we use is 2 blowers, forced air blowers, in order to provide the amount of air that the diesel engine needs. Another thing I want to point out is the main generator that's coupled to the diesel engine. This main generator actually produces an AC alternating current that we rectify to DC and then take that DC power and provide it to the traction motors. Alright, so where I'm standing here is where the engineer of the locomotive would sit. The engineer is responsible for the safe operation of the train. He has many different controls here that he has to use in order to move the locomotive. A couple of the options are the forward and reverse. Locomotive doesn't have a steering wheel, so you can only go forward or reverse, and this is the handle used for that. In order to increase the speed of the locomotive, each locomotive has 8 throttle notches. Each notch corresponds with a higher speed or higher engine generator output. That's to get the locomotive moving, but to stop the locomotive, you'll have to have air brakes. So this particular locomotive has 2 handles. The bottom handle is used to stop the locomotive itself, and the top handle is what's used called the automatic brake, which is actually the air that's used to stop rail cars connected to the locomotive. He also has the option for the horn valve to blow the horn, and he'll have air gauges here to monitor his train pressure at all times. Alright, so what we're looking at here is the what's called the engineer control panel. This control panel for this particular locomotive holds the screen, which gives us diagnostic information from the computer of the locomotive. It also provides circuit breakers, which turns on and off the different circuits of the locomotive. It also provides an option for the engineer to shut the locomotive off or to start the engine. So, in my personal opinion, as far as the future goes, possibly in the next 50 years, I personally believe that the locomotive itself will stay the same design as it is now, and the reason for that is the rail infrastructure. The rail infrastructure has been there for hundreds of years, and I don't anticipate that they'll change that. However, what they will change is what goes inside of the locomotive. Right now, there's a company that has doing some testing on an all-electric locomotive. That looks pretty promising. I think with the future battery technology, and when that takes off, it could be something that we'll see in 50 years. There's also a company doing some hydrogen power testing. I think the technology is not there yet, but in 50 years, it absolutely could be the future. I think once we reach a certain point, a diesel engine will be phased out. There will be a point where there will be zero-emission locomotives, and I look forward to that day.
Thanks for tuning in. As always, give us a like, shoot us a comment down below, and be sure to share this video with all your friends and family. And also, stay tuned for our next episode of STEM in Railroading.